inverse of functions today. And I guess the bottom line of this is there are lots of different ways to decide if functions are inverses of each other. What an inverse kind of looks like, to start off with, for example, if I told you y equals x plus 3, okay, and we're going to get to showing you how to do this in a second. Its inverse would be considered, and you put a little -1 there, that's how I know. I can't just call it the same name, right? If this is y, then this we call the inverse of y. That's the little -1, that's how you say it, the inverse of y, would equal x minus 3. Okay, and basically it undoes what you did to x. So if this was my original function and I added 3, its inverse would be to do what? Minus 3. It's kind of like you undo things, or you almost want to consider it the opposite, but not necessarily, right? That's one way to look at it in an equation. But there are lots of other ways to look at an inverse. What an inverse does, okay, is it switches all the x's and the y's, right? So for example, if I was at an ordered pair 2, 3, and I switch the x's and y's, where will I be? 3, 2. I'll be right here. Agree? I'm at 3, 2. And what you'll notice, and again, we're going to talk about this in a second, but this line I'm drawing in, it's hard to tell the screen, but this y equals x line, when you take an inverse of each other, when you flip the x's and y's, it hops over. It's reflective of the y equals x line. Okay? And we're going to make a huge circle and come right back to all of this, but I just had to find a place to start. So we're finding inverses today. What inverse does is it flips x's and y's. Okay? Or another way to think about it in an equation is it undoes what it had already happened. Added 3, now we're going to subtract 3. Those are like 2 or 3 different ways. Here is a definition of it, and you already have it in your notes, but it says an inverse is where all the points are reversed. And you'll notice, for example, here's 3, 4, and it turned into 4, 3, kind of like what I just said, remember? And when I do that, I'm reflecting myself. You know, we talked about reflecting over the x-axis, we talked about reflecting over the y-axis. Inverse functions reflect over the y equals x, that's the diagonal line, right? And the other one that it talks about here is, it shows you another example, is this. You know 2 points are inverses if their x's and y's are flipped. So that's one way to determine if they're an inverse. Okay. Another way, another interesting fact is that, and I'm going to talk about it now, like I said again, I'll circle back to the understanding how come we're talking about this. But a graph of a function, a graph is a function if it passes the vertical line test. We've talked about that before 1,000 times, right? You know a graph is a function if it passes the vertical line test. Agree? Okay. So, but here's like one step more than that. Okay. A function is 1 to 1 if it passes the horizontal line test. Well, we've not really done that before. What I mean by that is this. Okay. You can have a picture of a graph and it can be a function. But when you take the inverse, right, so in other words, when you flip the x's and y's, or I like to think about it more visually. In other words, this might be a function, but when I take its inverse, the new answer might not be. Okay, and there's a really cool test so you can tell. And it's the horizontal line test rather than vertical. Right? So let me show you what I'm talking about. If a function is 1 to 1, then its inverse is also a function. Okay, so this is what I'm trying to show you. I gave you a line, correct? If you're going to sketch this line, it would just be a line. Isn't that what it would look like? Now, let me ask you 2 questions. Is a line a function? Would it pass the vertical line test? Absolutely. So my question to you now is, do you think its inverse would be a function? Well, there's actually a way to check. And the way to check is, instead of doing a horizontal line test, if you want to see if its inverse is a function, you do a vertical line test. Would that pass the vertical line test?
No.
Vertical. Right. I don't know if this will work today. Let me try. If I drew a vertical line through this, yep, it would only one spot. So that means that its inverse is a function. So the answer to this one is yes. Okay. Let's try another one. Number 2. Do y'all remember the shape of an absolute value? No, value, absolute value. Yeah, sorry, we're going to 2 on the side. Sorry about that. It's a V. Obviously, yes, it's a function. It passes the vertical line test. My question to you, though, is if I found the inverse, in other words, if I switched all my x's and y's, or if I flipped it over the y equals x axis, which I'm going to get colorful here. If I flipped my v over this, if I wanted to know if it was a function, the way you test is you check a horizontal line test. Would this pass a horizontal line test? No. Good job. It crosses in 2 spots. So it would not. So we're going to call so this is not 1-to-1. In other words, even though this right here is a function, its inverse is not. Okay, because it doesn't pass the horizontal line test. That's a no. What about number 3? What's the shape of number 3? Parabola. It's a function, right? It passes the horizontal line test. Do you think its inverse is a function? Does it pass a vertical line test?
Vertical, yes.
Oh, good job. I said the wrong word. Thank you. Does it pass a horizontal line test? Right, if I do a horizontal line, I'm going to cross in 2 spots. So the answer again is no. Yes, a parabola is, but its inverse is not. Okay? Go to the next one. What shape is the square root picture? It's the hill. Excellent. Out 1, up 1. Out 4, up 2. Remember? It is a function. Is its inverse a function? Would this pass a vertical line test?
Yes.
Keep saying vertical. Would this pass a horizontal line test?
Yes.
It passes both, doesn't it? If it passes both, the answer is yes. It's a function and its inverse is a function. Because look, it would pass a vertical test, so you know that it's a function. It would pass a horizontal line test, so you know it's both. So this is a yes. Okay, this is different. I gave myself a restriction. Draw a picture of that picture. Draw a picture of that function. X squared plus 1, it's of u. And my restriction is x can only be bigger than 0. Greater than or equal to 0. So normally this is my parabola, but if x can only be equal to 0, which part of my parabola do I want? Correct. I just want this part only. Oh, I did forget to go with 1. Okay, but it's not going to affect what we're doing. Good job. Thanks for seeing that. Okay, so that's what my picture is going to look like. It's a function, yes. Passes the vertical line test. Is its inverse a function? Does it pass the horizontal line test? It passes both, correct? So we're going to go with the yes. All right, so now, yes, ma'am.
What if it doesn't pass the vertical line test, but it passes the horizontal?
Well, then the original wouldn't have been a function, so it would still be no. It would be yes and yes. Okay, so we found 2 different ways to look at inverse, right? Our first way was flip x's and y's. Agreed? Our second way is check and see if it passes the vertical and horizontal line test. Okay? Now to the strange part here. If 2 functions are inverses, it can be seen algebraically and graphically. We've looked at it graphically. Now we're going to look at it again in an algebraic way. Okay, and let me go back to what I was showing you a second ago, this part right here. We're going to talk about this x plus 3, this. Okay, if I tell you that, if I want to know if these 2 things are functions, if they are inverses of each other, well, in order for an inverse to happen, you do something to it, and then you undo it, correct? Aren't those exactly opposite? I added 3, and then what did I do here? I subtracted 3, okay? So I'm trying to get you to understand the general idea of this. So watch. If I start with x, okay, and watch this part because this will make a lot more sense. And I do what it said here. I add 3. But in in my inverse, what did I do? I subtracted 3. So what ends up happening? What do these go away and you get what? X's. So a way to be able to tell if you have two functions, here's one and here's the other, if I want to know if they're inverses, okay, if I simplify it and you end up with x, in other words, if I do something and I undo it, if I get x, then yes, they're inverses. Because watch, for example, what if I told you, hey guys, x plus 3 has an inverse, and its inverse is x plus 3. Okay? Then an inverse is undoing what just happened, correct? So let's check. Well, I started with x, I added 3, and then to do something else, I add 3 again, and I get x plus 6. Does that get me back to where I started? Do you see the difference? So without graphing it to look and see if I flip over this green line right here, you can actually do it mathematically. And what do you think your goal is to get? X plus 6 or x in order to tell? Which of these do you think are inverses? When I plug them in, I get x, or when I plug them in, I get x plus 6. What do you think my goal is? To get x, right? To try to undo everything I just did. Right, so let's go to that. So two functions are inverses if the following things are true. In other words, I'm going to look at number 1. You have to take f of g of x. In other words, you've got to take g and plug it in to f. Then, you do one more thing. You take g of f of x. In other words, you take f and plug it into g. Both ways. And what do you think I'm trying to get here? I'm trying to get x. All right, so let's try the first one. Okay, on the first one, we're going to take g. Or not. We're going to take g. And plug it in right here. So this x goes away completely. Do y'all remember doing that? So let's write what we had then. The x goes away and we're going to write 2x plus 1. What else is left on top? All I did, come on guys, so if you're not focusing, this is an easy lesson. It's only easy if you listen. Come on. Okay, so I plugged this in for x. What's left on top? A minus 1. What's left on bottom? A 2. Excellent. So and guys, think about this common sense wise. Listen to me for a second. When I came to here, okay, I subtracted 1 and divided by 2. Let's look over here. I added 1 and multiplied by 2. Do they sound like it's pretty opposite? Yeah, but they're making me prove it algebraically, so that's what we're doing. They did exactly the opposite. They undid everything, right? So if I plug them in for each other, everything's going to cancel out. So look at the numerator. This cancels, and you end up with 2x over 2. What happens with the 2's? What do we get to do with them? They go away, and we get x. You go the other way for me. Try it. Go the other way. Because you have to prove both ways. Okay. You try the other way, please. This time we're going to go the other way. We're going to take this entire huge fraction and replace it. This is going to go away. If you struggle with your algebra, then watch me and I'll do it slowly for you. You end up with a 2, which is right here, times that huge fraction, which is x minus 1 over 2. So there, I've got the 2, I replaced the x, and now don't forget about your plus 1. What happens here? We're going to take care of this giant mess here. What happens to these 2's? Good. They cross out. So now you have x minus 1 plus 1. These cancel and you end up with x, which is what we were hoping. Right? We plugged each other in. We got undid everything. Everything canceled. And now I know, guys, that f and g are actually inverses of one another. If I graphed them, they would be a reflection over. If I graphed them, it would be a reflection over that y equals x line. Okay? Oops. Go to number 2. Read the directions so you understand what you're trying to do. Are the functions inverses justify your answer? How do we do it? We do f of g and then we find g of x. We do both. Let's start with f of g of x. You're going to take this huge fraction, you're going to plug it in for x. It goes away. So we have a 2 times that entire fraction. Don't forget about your plus 3 on the end. Okay, what happens to the 2's? They do what, guys? Cancel, and you left with x plus 3 plus 3. Wait a minute. Are they going to cancel? No. You end up with x plus 6. So you can actually just stop. Are they inverses of each other? No. If you get x, you have to do it both ways. Now, guys, let's use a little common sense. Go back over here to this problem and look at what it said. It said 2 times x plus 3, and this said x plus 3 divided by 2. They look very close, don't they? But order makes a difference. Okay, this will multiply by 2 and added 3. This added 3 and divided by 2. What should this plus 3 be if we wanted it to be? Right. Everything has to be undone. Okay. All right, go to the next page. The one that's upside down. Sorry. You know, some movement every now and then. Does it look like this? Right? Okay. I kind of talked about this already, but it says graphically. 2 functions are inverses if they are reflections over what line, guys? What did I tell you? Y equals x. And it makes sense to me because you flip the x and y, right? So if you see what I'm saying? So therefore, it's a reflection over the x equals y. Right? I'm going to, with a highlighter, draw the y equals x line. And if you can as well with something that will make life a little easier. So that's my y equals x. Right, and then let's do me a favor, graph both. And if you can, in different colors, that might be easier. So I'm going to graph the first one, line 1. We're going to start at -6. And I have a slope of 3 over 1. So rise 3 over 1 and so forth. If you aren't using 2 different colors, then you might just label them line 1 and line 2. Okay, so here's my line 2. Up 1 over 3. Up 1 over 3. Up 1 over 3. Makes sense? So graph that other line for me. Usually you can see is for 2. Start at 2, go up 1 over 3. Here's another line. Do they look like a reflection over the highlighted line? They do, don't they? You could just fold the paper on the highlighted line and it would touch each other. It would just work. Do what? What? The highlighted line? Oh, okay. Alright, now let's go to the next part. Okay. I told you a second ago about this x plus 3x minus 3, that they're inverses of each other. I'm going to teach you how to find an inverse mathematically. Right? Let's start with the first one. We start here. It says sketch a graph. So why don't you do me a favor and go ahead and graph the y equals x line again. I think it makes it easier to see it. So graph your y equals x line if you'd like to. You don't have to here. And then the directions say, sketch a graph of your function, okay? And here's my function right here. These go together. So let's sketch this graph. Down 4, my slope is 3, 1. Come guys. There's my original. Okay. And then it wants me to find the graph, the inverse. But did it give me the inverse? Look right here. Look what's missing. Is there anything in the box? No. There's nothing there. You have to find the inverse. There are 2 steps, so somewhere write me down the 2 steps for me, guys, please. Here's your 2 steps for finding the inverse. Step 1, switch, it's very easy, switch x and y. Remember, and now an inverse is, in the very beginning of our notes, we talked about that. Okay, so just switch them. If you see an x, what are you going to turn it to? A y, and when you see a y, you're going to turn it to an x. Okay, step 2, solve for what? Solve for your new y. Those are your steps. Okay, Keith, you want to try it? I'm going to do it in pink so that it fits my pink box. You know what I'm doing. So I start up, I have f of x. What are we going to call f of x, you guys? Good. Y. Thank you. So y equals 3x minus 4. What was my first step? Switch what? X and y. So we're going to call y x now. And we're going to call x y. And what's step 2? Excellent. Solve for y. So move your 4 over. And then divide everything by what? 3. Divide everything. Each piece. I realize there's no number beside x. What number is there that it's not written? 1. Okay, now, algebraically, can you all look up here for a second? Okay, I don't like to write my y on the right, so I'm going to write it on the left. And we don't use it as y, we use it as y to the negative 1, right? We already have a y. Y is 3x minus 4. And then let's write 1/3 x. Do you see where I got that? 1 over 3x plus how much? What's left? 4/3. so it's written as f of negative 1, and that's the same thing as y to the negative 1. Same thing. Write it down 1/3 x plus 4/3. 1/3 x plus 4/3. Now graph the line, please. Graph me the line and tell me if you think it flips. Where do you start? It's kind of weird. Where are we going to start? Where's 4/3? A tiny bit over what? 1. Just start on the y-axis, a tiny bit over 1. I'm going to start a tiny bit over 1. And I'm going to hop up 1, and I'm going to hop right 3. Hop up 1, right 3. So if I'm already kind of a little bit above, you just hop a little bit above. And draw your line. Kind of hard to see, but does the pink line and the black line look like a reflection over the y equals x line? In other words, does this line here look like a reflection of this line? Check. Hop. Hop over the yellow. Yes. Hop over the yellow. Yes. Do you see it? They're reflections, aren't they? So are they inverses of each other? Yes. Okay, the question now, look right here. It wants me to find the domain and range of this. So here was my function. Here's my inverse. Find me the domain and range of the inverse. That's what it's asking. Are y'all seeing that? Watch. Function original, inverse. Now find the domain and range. Okay. What's the domain range of the pink line? All real and all real. Excellent. I'm going to use pink also so it's easier to see. Okay, so the pink line is the domain range is all real. All right, try the next one. Okay, I'm going to, it says graph both lines. So I'm going to put this around in black and number at line 1. I'm going to do the same thing. I'm going to make my y equals x line. You're not required to do this, but it sure makes it easier to check. I'm going to graph it. That last period too. What did I do wrong just now?
You were not zero because the after is with the x.
Excellent. I went the wrong direction. It's with x, so you go left and right. So I should have gone left 3. And then to graph the hill, it's out 1, up 1, out 4, up 2. When you graph, do me a favor, cross over the yellow line, keep going. It's going to make you see the flip easier in your head. Just kind of go past it a little. Okay, do you think you can find me the inverse? Do you remember how? What are the 2 steps? I wrote your 2 steps up above. Yeah, I'm going to switch colors. So the rule for this, we don't have it, so I'm going to fill it in just a minute after I find it. I didn't leave us very much room to find it. Okay, so if we're going to find it, guys, I'm going to do the math right here because I don't have a lot of space. So I originally had y equals the square root of x plus 3. If I want to find the inverse, what's step 1? Flip x1. So now I've got x equals the square root of y plus 3. Come on guys, focus on this. We're almost done. I've got this one and one more. Alright, now what? How do I get rid of that radical?
Square root. I'm sorry, square root.
I know what you meant, right. In order to undo a square root, we have to square it. So no problem, let's take care of that. Square both sides though. So So now then x squared equals, it's going to drop the radical y plus 3. Now what are you going to do both sides? Move the 3 over. So x squared minus 3 equals, and we call it y to the negative 1. How come? Why do I have to put that negative 1 there?
Just the inverse.
Yeah, you've got to communicate to me it's the inverse. It's not the original function. The original function was the square root of x plus 3. The inverse is x squared minus 3. Now look, if you write, oh, I should have done it all in pink, I'm sorry. So this became x squared minus 3. If you think about this for a second, this was take x, take the square root and add 3. I squared it and subtracted 3. Isn't that everything exactly undone? So yes, that's the inverse. So graph that please. What shape is it? There's a problem though. It is a parabola, but when you get ready to graph it, what does a parabola look like, guys? It's a U, isn't it? Well, if I put a U here, I'm going to use a pencil because I'm going to have to erase it. I'm going to drop down 3. There I am. Do you agree? Okay, and this is out 1, up 1, out 2, up 4. So make your parabola. I'm using a pencil because we're about to erase. Look what I just did. I drew the right side of my parabola.
Oh, so you have to put the y can be.
Yep. It looks pretty good, doesn't it? If I put the left side of the parabola up, is it going to make any sense? Look, does that work? It doesn't. So I'm going to erase the left side. So what does it mean? It's okay to use this, but what do we have to tell it? It needs a what? A restriction, right? What's the domain only allowed to be? What's the range only allowed to be? The domain has to be what?
All the numbers that y is greater than 3.
Wait, domain. X's. You're going the wrong way. You're telling me ranges. What x value can I use? From 0 to what? Infinity? Or if you like it better, you can say x has to be greater than or equal to 0. Either way. What about my range? Good. You can say negative 3 to infinity, or y is greater than or equal to negative 3. That should be bracket. Got it? Try the next one. I think it's the last one, right? This is it. Come on. Do this problem, learn it, and then you've got this material. And that's all you had. This is your last lesson before your next test. Say it again.
We could move it again tomorrow.
Okay, you'll notice it gave me a restriction. It has to. When I get ready to graph x squared plus 2, what am I only allowed to do? The domain can be what? Greater than or equal to 0. So when you graph it, be sure you follow that. Now then we're going to find the inverse. My original function was y equals x squared plus 2. Can you guys remember, how did I find an inverse? There's 2 steps for finding an inverse. What's my first step? What did we say? Flip what? Flip x and y. What's step 2? the 2 over. Then what are you going to do? How do you get rid of a 2 squared? Take the square root. So now the inverse of y equals the square root of x minus 2.
So the 2 is involved with that.
It has to be in it.
Alright, that makes more sense.
Oh, it's going to look better, yeah.
It's like, I didn't know if it was part of
Because you take the square root both sides, right? Is there a restriction on the domain? Not necessarily. You don't have to put one on there because it fits already. We already put the restriction on the parabola, right? A parabola is going to have, look guys, a parabola, an x squared is going to have a restriction because it doesn't pass the horizontal line test. So I know its inverse isn't going to be, is that going to work unless I put a restriction on it. So the domain is, I didn't graph, sorry, right to you're almost finished with the notes. Write me the domain and range. Domain would be from 2 to infinity, or if you wrote x is greater than or equal to 2. The range y is greater than or equal to 0, or from 0 to infinity, either way.